Hello everyone, today we will see the memory allocation in C. Okay, we will see this. Before we proceed to this, you should know some basic things, such as I am just drawing the basic flow on that C program. Here I have a compiler. Okay, that .c file or C program files that compiler will compile. Okay, so here I have a linking process is involved, and that linker, here I have a memory layout. Here dot data section, dot text section, sorry, dot bss, then dot text section, heap, and one more, that is dot stack. Okay, when the compiler take our C program files, at the same time the linker, I am using here different words, that linker, linking, linker script, etc. Here, sorry, I forgot. Here that's linker script there. Okay, I am using different words, so we will see one by one in after. Okay, so just you should have a basic understanding how this memory, or data is stored in a memory. Okay, when compiler takes our C program files, at the same time the linker follows the linker script and put the data, or you can say variables or data, in this memory layout. Okay, and I'm going to explain you that there is involved a linker script in this process. Even if the user don't provide it, it uses one that comes with a GCC. Okay, different words are there: GCC, linker script, linker. We will see one by one there. One more thing you should know before we proceed for memory allocation. Okay, you should know what is an hosted environment and freestanding environment, because we are going to discuss on the basis of that. Okay, so first we see what is an hosted environment. Okay, if the code runs on operating system, if the code runs on OS or operating system environment, okay, it means the compile code is loaded by OS. Also right, compile code is loaded by OS. Here I said or. Okay, this means same. Okay, another is freestanding environment. People also say this as bare metal programming. You have knowledge of this. You should write clearly bare metal. Okay, in which hardware programmers are there. Hardware programmers loads the C code. Okay, I just have given brief idea of hosted environment and freestanding environment, because you should know what is this. Okay, we will start our discussion further. Memory allocation. Okay, memory allocation. Two types of memory allocation is there. Okay, first, static memory allocation. And another one is dynamic memory allocation. These are two types of memory allocation. We will see one by one which is useful and which is not. Okay, on the basis of application, these both are used. We will use simple words to understand this. Okay, so what is static memory allocation means? The memory allocation in which the memory where the data is going to store, or how data, which type of data where to store is decided before the program runs. Okay, before program runs, these things are decided. And in freestanding environment, it is decided by the compiler. Okay, in OS environment different things are there. Okay, and in dynamic memory allocation, the allocation of memory is done at runtime, in which allocate the memory at runtime. Runtime means the program is running, during that time the allocation is done. Here we use malloc, free, calloc and realloc functions, alloc function, to do the memory allocation at runtime. Here mostly the stack is used, means by compiler, the stack compiler uses in stack. Okay, I am just drawing the basic sketch of static memory and dynamic memory. We are going to see deep how this works, and we are also going to see the pros and cons of this. Mostly this static memory allocation in embedded system, this kind of is used. Static memory allocation is used. Okay, we will see why